Hi everybody, I am Dr. Harita, Professor in CSC. Today I am going to explain you about stories classes and what are stories classes and their significance in writing your C programs. Right? So what is it? Before we start that, before you learn anything new, you should know what it is and what is its significance, what are its uses and why you should learn this, and how it is helpful for you in developing your own applications. That is a later level of your taxonomy, applying and applications. Let us first try to understand at this stage what is a stories class. A stories class specifies the features of your variables. It is in simple, it only specifies or describes the features of your variables. What is a variable? A variable is a named memory location. So whenever like this, right? Whenever I declare a variable like this, A is an integer variable. The moment you declare a variable like this, at the time of compilation, internally in your physical space, memory, this will be allocated to some addressed cells. Your entire memory is being addressed. Each slot or each byte of address is being addressed. Memory is a collection of addressed cells. It lets you store your data, and that is, you decide whether you want to store it permanently or temporarily. Normally the data you store in RAM is volatile. As long as your program is in execution, you can see your data, right? So this is A is a variable, and normally I can say that a variable is a name given to your memory location. And whenever you declare a variable, suppose after this if I write A is equal to 7, that is the value of your variable. To store this value only we require variables. Whenever you declare a variable, each variable has 3 values. What are those? One is the name of the variable, another is the address of the variable, and the other one is your actual value being stored in the variable. Yes, right. So for this variable you are giving some keywords, you are preceding some keywords under the category called as stories classes. They will they will specify the features of your variables. What are the features of your variables is scope, visibility and lifetime. Scope, visibility and lifetime. Understood? What is this? What is the life to a variable? You may wonder, is it a living thing? Then what is the lifetime? Yes, lifetime means how long it is going to retain or preserve the value. Here the value of A is 7. How long it will retain this value, stores this value, preserves this value, tells you the lifetime of your variable. Its purpose is to store the value. If it is unable to store the value, then there is no meaning of its life. That's what it is. And then what is scope and visibility is? See, C programming is a function oriented programming language. Means you can have n number of functions based on your requirement. You divide the problem into sub-problems that means sub-functions, and combine it. So in a single program you can have more than one function, and where it is declared and whether it is accessible to, and that is whether it is accessible and visible to all the functions or within the function only it is defined, tells you about scope and visibility. I am able to access this, and if so, I am able to get the value of this in any function or any block. Within the block it is defined or outside the block it is defined. That and all will be specified by the features and by these storage classes. Storage classes, the moment you see, each storage class has a specific predefined meaning that you should know, and the moment you see, you can able to understand what is it, right? Understood? So there are 4 types of storage classes. Here it is: automatic storage class, static storage class, register storage class, and external storage class, right? So the keywords for all these storage classes: auto, static, register, and external, right? First let me start with this automatic storage class. The keyword for, see, all these keywords must precede your declaration. You know, the basic declaration is to declare an integer variable is int a, and all these storage classes keyword must precede. Suppose if I want to make this as an auto, that keyword must precede the variable declaration. That is the syntax to go to work with this. And as I said, all these keywords has predefined meaning with the language. The moment it observes auto keyword in the variable declaration, the compiler understands, okay, it is an automatic variable. And see, you may, by this time, see, you are not using these storage classes. Is it mandate to write a storage class? No. Based on your requirement, based on your application requirement, you can use this. It is an option, and it is a flexibility to the user. Based on his requirement, he can choose the respective storage classes. Then what happens if I don't use anything? By default it is auto. If you don't specify externally, specifically if you don't specify anything, it is an automatic storage class. Understood? Make sense? Yes. Then what is the meaning of this automatic variable? What happens whenever I write a auto, or by default it is an auto? Auto is whenever you declare a variable, right? Suppose if I write a function, void function, inside this function if I declare a, and I will work on this, and I have several more functions in my program. Right? But what is the scope, visibility, and lifetime of an auto variable is within the block it is defined. It is visible, accessible, and the scope is within the block it is defined. It cannot be accessed, or its value cannot be retained outside this function or block. Understood? Yes. I'll tell you, I'll explain with example also, but try to understand what are this. Then coming to the next storage class called as register storage class. The keyword is register. If you observe, other than this register storage class, all the storage is RAM only. And I'll tell you what are the initial value for this auto variables and storage class variables is garbage. If you don't initialize, it retains with garbage values. And I'll tell you both auto and register storage classes are same. Their scope, visibility and lifetime is confined to the block where it is defined. Then you may ask a question, why? Then why, if both are same, why should I need one more category to represent the same storage class? No sense, right? Both behaves the same. What is the use? Here, it is very important to notice, suppose if you want to make your program to be very effective with respect to the execution time, that is, if you want your program to be speed significant, yes, if you want your program to be consume less CPU time, fast enough, in that case we would prefer you to use your all variables, local variables to be register. Why? And how it is possible to be fast enough is, instead of storing your data in RAM, it will store in CPU registers. The compiler stores you, assigns one CPU register to the variable instead of a memory location in RAM. So accessing CPU registers is faster when compared with your RAM access. But it is suggested not to use always unless your application demands. Why? Because CPU registers are limited and costly. Alright, makes sense? So both auto and register variables has scope, visibility and lifetime is confined to the block where they have defined or declared. The initial value is garbage, default value is garbage. Yes, right. And then move on to another variant of your storage class called as extern. Extern. And the default value for extern variable is 0. And this is a variable, you can call it as a global variable. That is, if you declare a variable outside of your main, outside, before you start writing any of your user defined functions, if you define a variable, that variable is claimed to be a global variable. By this time you all know, right? So their scope, visibility and lifetime is throughout the program. Such and such variable can be accessed in any block, even though if it is defined or declared elsewhere. That's what they called as external storage class or global variables. Yes, and the next and very important is static storage class. They are very beautiful. So for a static variable, so if you declare a static variable, static int s, the initialization will be done only once, that is 0. Initialization will be done only once, that is 0, and the scope and visibility is within the block only. Scope is within the block, but the lifetime is throughout the program. How is it possible? Is it will retain the values. It will retain the values between the function calls. It preserves the value. The lifetime of the variable is throughout the program. The value will be retained. It won't be changed unless you forcefully change in some function where it is, its scope is there. Right? Suppose if you want to write a program where you don't want to retain it, if you want to retain the value, even if your scope and visibility is out, if your variable scope is out of the scope also. In that case, you can make use of a special category called as static. Static variables are more significant and their use is very significant in writing programs. Let me explain these 4 categories with examples. All right. Right. Students, see here. So, in this, the first one is an example of an auto. See here. Here it is a function, my function. Inside it is an automatic variable. By default it is auto. If you write auto or not, it behaves like an auto variable, and simply print. Right? And in main, simply a function call to my function. Another my function call to my function. 2 times my function is being called. Right? So, in between, if I write a statement after initializing a is equal to 10 and after printing this, suppose if I write a plus plus, what happens? What is the output of this code snippet? A is initialized with 10, and then output is it will print the value as 10, and then it will increment a by 1. And it leaves the function after first function call, right? What is the first executable statement in C? Main. So, if I try to execute this, so it will start with main and then the next statement in sequence is my function, right? So, immediately the control goes to the called function here, and then it will execute the statements in this function one by one. Int a is equal to 10 and then prints a value as 10 and then increments a by 1, that is now a will become 11. Yes, here a will become 11. Yes, yes. After this, end of the function. Once the call function reaches to the end, it must return to the next statement that follows its function call. Therefore, after executing this, the control goes to the next statement to the function call. Once again, it is a function call. The moment the control sees a function call, it is a high priority interrupt. Immediately, it goes to the next called function once again. What happens? Once again, it will be reinitialized into 10, the same, n times if you call also same. If you try to access A here, if you try to print A is equal to some 7, if you try to write, it won't be accessed. The scope and visibility of this auto variable is within my function only. If I try to access outside that, it won't be. It is wrong. Yes, all right. Then a resistor is same, and this extern, the last one is an extern. Extern, if you put in extern, it will be accessible to any function within your program. Any function within your program. Right? See here, my function. Where it is declared? It is declared elsewhere. Here it is declared. It is neither declared in your my function nor declared in your main. It is declared globally outside the function. So that it says that it is globally available to all the functions in your program. Extern. So its life, visibility and scope is throughout the program, even though it is declared elsewhere, no other than the block it is going to be used. See here, it is accessed normally as if its own variable in main, it is accessed as if its own variable in my function. Whereas A is owned by my function. Here in this auto, it cannot be accessed by outside functions. It is wrong. Why? Because it is an auto. See, observe, with a simple word, keyword, its accessibility, its lifetime changes. That is, you are restricting their access and lifetime by a simple word. Understood? Yes. And then move on to storage, which is my static, which is my favorite storage class. The moment you write static, even though its scope is A int A, it is declared in my function. So its scope and accessibility is only confined to my function only. It cannot be accessed outside main, outside my function. I cannot access A here. If I write A plus plus, it's a mistake. Same as your auto and resistor. But the beauty here is it stores its value even though it is out of scope. Right? That's why the first time if I called, what happens? Initialization will be done only once. The control immediately goes to the call function. A is equal to 10 and A is equal to A plus 5. Now what is the value of A? 10 plus 5, it is 15, and it will print A and exits. The moment it exits, it has to go to the next statement that follows the function call. It is once again a function. Observe the difference between auto and static. Same code is being written for both the explanations, but observe the output. It goes to the my function. Initialization, no, will be done only once, and then it will execute this statement. A is equal to A plus 5. 15 plus 5, how much it is? Now A will become 20. A will become 20 and it will print 20. And every time A gets incremented by 5. For every my function call, A gets incremented by 5 times. Suppose if I remove this static, what would be the output? Guys, what would be the output? Always 15. Anytime you call, the output is 15. Why? Because it will be initialized, it will be actually incepted for every function call. It will be recreated. The moment you exit the function, all local auto variables will vanish. The moment you call the function and it starts executing the call function, all will be alive, re-alive, will be recreated, reinstantiated. But whereas with a static variable, it will be created only once, initialized only once. If you don't initialize explicitly, the default initialization is 0. And it retains the value between the calls. That is the beauty of your static storage class. Understood? Make sense? Yeah. Right? So practice few problems on this. Get the workbook and practice few problems on this so that you get confidence on this. So any problem you practice, you get confidence, and once you get confidence, that leads to competence. Right? So I guess the session went on well and you have all understood what is a storage class and what is the lifetime and scope of a variable. Right? Here you have a few self-assessment questions. You can work out on this, and these are all the reference and links, books and links for your further reference. Thank you so much.